Drop a modern human into the wild with nothing but their bare hands and they'll starve. Not because there's no food, there's plenty. Roots, leaves, raw meat, whatever a chimpanzee eats fine every single day. The problem is you. Your gut is too small, your jaw too weak, your teeth too dull to get enough calories out of any of it. This isn't theoretical either. Modern raw food devotees, the strict ones who refuse to cook anything, run a real-world version of this experiment every day. Even with unlimited access to fresh produce and meat, many can't maintain a healthy body weight. Some long-term strict raw vegans even stop menstruating because their bodies physically cannot extract enough calories from unprocessed food, no matter how much they eat. Somewhere in the last couple million years, your body made a bet that humans would always have access to fire, and it bet everything on it. This isn't a metaphor. Cooking isn't just something humans do, it's something our bodies now require to function. So how did the choice to throw food on a flame end up rewriting human anatomy itself? In 2009, primatologist Richard Wrangham laid out an idea that reframed the whole story of human evolution. He called it the cooking hypothesis. The short version, fire didn't just make food taste better, it made food worth less effort to digest, and that extra energy didn't disappear, it got rerouted straight into building bigger brains. Here's the biology behind that. Raw food takes enormous energy to break down. Chewing it, then your gut grinding through tough plant fibers and raw protein, burns calories just to extract calories. Cooking does a huge chunk of that work for you before the food even reaches your mouth. Heat unravels proteins, breaks down starches, softens cell walls. The same plate of food, cooked, can hand your body significantly more usable energy than it would raw. Wrangham's team even tested this directly. Pythons fed cooked meat digested it faster and spent less energy doing it than pythons fed the exact same meat raw. Same calories on the label, very different cost to actually use them. That's not a small bonus. That's the kind of energy surplus a species can spend on something expensive, like a brain that eats around 20% of your daily calories just sitting there thinking. Anthropologists Leslie Aiello and Peter Wheeler proposed an idea in 1995 that's basically an energy budget for your whole body. They called it the expensive tissue hypothesis. Big guts and big brains are both incredibly costly to run, and evolution usually won't let an animal afford both at once. Something has to shrink to pay for the other. Compare a human gut to a chimpanzee's, adjusted for body size, and ours is dramatically smaller, especially the large intestine, the part built for grinding through tough raw plant matter. We simply don't need that machinery anymore. Cooking became our pre-digestion system, and the gut downsized to match. The energy saved on digestion lines up surprisingly well with the energy our unusually large brain demands. Then there's your face. Compare a human skull to species like Homo erectus or earlier, and you'll see jaws and teeth steadily shrinking over time. Raw, tough food needs serious chewing power, big molars, strong jaw muscles, sometimes even a bony ridge on the top of the skull just to anchor that muscle. Cooked food is already soft. It needs far less force and far less time in your mouth. There's a specific genetic fingerprint on this too. Around 2.4 million years ago, a mutation hit a gene called MYH16, which builds one of the major jaw-chewing muscles in primates. In humans, that mutation essentially switched the muscle off at full power, and our jaw muscles shrank dramatically as a result, along with the bone they used to anchor to. Softer food made a smaller, weaker jaw survivable. A smaller jaw, in turn, may have given a growing brain more room in the skull to expand into. Chimpanzees spend close to half their waking day chewing. Modern humans on a cooked diet spend under an hour. That's hours of freed up time every single day, time that used to go entirely into grinding up raw food, suddenly available for literally anything else, including probably figuring out fire in the first place. Now here's where it gets messy, and credit to the skeptics because they're not wrong to push back. Wrangham argued these body changes line up with Homo erectus, which would put habitual cooking at around 1.8 to 2 million years ago. The problem is solid physical evidence, actual burnt bone, structured hearths, ash layers we can confidently date doesn't show up that early at most sites. The earliest unambiguous, repeated evidence for cooking comes from sites like Qesem Cave in Israel, dated to roughly 300,000 to 400,000 years ago. That's a gap of over 1 million years between the body looks adapted for cooking and we can prove cooking was happening. There's one wild card, though. At Wonderwerk Cave in South Africa, researchers found ash and burned bone they've dated to around 1 million years ago, which would split the difference and push real evidence much closer to Wrangham's prediction. But that site is contested, the sample is thin, and most researchers still treat it as suggestive rather than settled. So either humans were cooking far earlier than we have solid proof for, and the evidence simply didn't survive, since fire leaves notoriously faint traces over 1 million years, or something else drove those early body changes, and cooking just exploited a digestive shortcut that was already underway. Nobody's claiming this one is fully settled. What's not debated is what happened once cooking became routine. It changed how humans behaved around each other, not just what they ate. A fire that has to be tended forces a group to actually sit still together, at the same time doing nothing but waiting for food to finish. That's not trivial. Most other primates eat the second they find something, wherever they are, usually alone or in quick competition with whoever's nearby. Humans invented the opposite, a scheduled, shared meal. The first dinner table was a ring of dirt around a flame, and once you've got everyone sitting in one spot for 20 minutes with nothing to do but wait, you've accidentally invented the first regular venue for conversation, storytelling, and whatever the Paleolithic version of gossip looked like. Fire also pushed back the start of night, buying early humans extra waking hours in relative safety, away from the heat and predators of the daytime. Some researchers think the fire camp did almost as much for human social bonding as it did for human digestion. So the next time you throw something in a pan without thinking twice, remember what's actually happening. You're not just making dinner taste better, you're running a process your ancestors outsourced to fire so long ago that your body forgot how to live without it. A smaller gut, a smaller jaw, a bigger brain, all paid for by something as simple as heat. Cooking didn't just feed early humans, it built the version of you that's watching this right now. So here's the real test. Could you actually go a week eating only raw food? Not just salad, actual raw meat, raw roots, the whole diet, the way your body apparently isn't built for anymore. Tell me in the comments how long you'd last. I give most of us about 2 days.